small pieces of toothpicks. It's process engineering, right? Again, you have your fruit. We have lots of fruits in Nigeria, in Ghana, and these fruits we pluck them from the tree and we eat them. We pluck them from the tree and we just eat them. We consume them. But also you can process them into juices by squeezing out the liquid. Now you are separating the liquid from the solid. If you remember your chemical engineering or your separation processes, this is solid liquid extraction. That's basically it. So you have the small container, you squeeze the orange on the squeezer and you get the liquid on the other side, if you can picture what I'm talking about. You have just separated the liquid from the solid. For you to scale this process to a larger process, you need to perform calculations, you need to perform some operations, designs, and whatever, drawings, and the rest of them. All of these activities, they are all process engineering. Okay? Even in your body, you have you breathe in oxygen and then it goes through the system and through your body system to your respiratory system. Your blood is pumping through the system. You have your brain is performing calculations and logic, helping you to make decisions how to move your arms and your legs and your eyes and your ears and everything. Now, all of this process engineering. You are processing information. You're doing something. Doing performing an action or whatever. Okay. Now going back to the industrial part, process engineering. Okay. Uh, these are different. Process engineering is like a model term that has to do with a lot of things, but the end goal remains the same: raw materials to finished good. Now, what you see on the screen are different sub roles under process engineering. These are different sub roles under sub process engineering, of which some of you might already be playing this part in your either in your career where you're working or in on your IT, you're doing your industrial training, or even as a student in your projects, you might be performing this role without even knowing that you're already doing this. So what I'm going to do today is to demystify this and for you to realize that, okay, what you're actually doing is important. It's going towards an end goal, right? Your activities as a process engineer right now in the school is very, very important. In fact, the structure of the program which you have done or you are doing is designed to drill you and prepare you for the industry. Like, is perfect. The educational level is okay. It's actually okay. So this is to remove the doubts you might have already that, okay, maybe I studied and I'm applying for jobs and not getting jobs yet. That's not true. So this is where the self-sabotage comes in. And we're going to demystify it. We're going to remove all that today. Okay. Now, without forgetting the other engineer we have here, which is the computer engineer or the IT engineer, their role are also important in the oil and gas industry or whichever industry that has to do with processing of raw materials to finished goods, such that Caleb mentioned where you have to monitor some instruments in the field that will take readings of pressure and the temperature and some other physical parameters. Now you need logic to be able to compute this information. You need logic to compute this information and make decision. Now, this is the responsibility of the guy who has to handle the automation part. He has to ensure that the system is reliable and robust enough to handle this operation. Now, okay, uh, if you want to cook soup, or let me use for example, you want to make what's the most desired soup we have in Nigeria? It's probably uh, or food generally. For the people in the West, it's usually a wedu, I think, a wedu. For the South, I think a gusi, Around Edo should be granite soup or black soup. I don't know. I'm not sure, but probably. Then in Ghana, Banku, of course, Banku and Kenke. This is usually the favorite delicacy. Now, you are cooking any of this food, and you have to add ingredients in it, right? You could, um, if you add excess salt, it becomes terrible. You can't eat it, right? And because this is a manual process. Now, for you to scale up a process that's going to be producing, someone said, Dami said egusi is general. Yeah, egusi is actually general. Almost everybody eats egusi. I don't know about people in Ghana if they always eat egusi. I once ate Ghanaian egusi soup, but I would say it didn't taste as much as the way I would say I loved Nigerian egusi soup. Sorry, uh, what's her name again? Um, our Ghanaian, Shahima. Sorry,
Yes,
Shahima. Yeah, but you understand what I mean. Don't worry,
yes,
no shades.
Ghana
So,
Sutra. Yeah.
if you want to have if you want to produce if you want to build an industry that's going to be producing egusi soup, it needs to be consistent. The content needs to be consistent. For example, your Coke bottle, you have the ingredients listed there, and these ingredients you have certain percentage of the content that was used to make this Coca-Cola. For you to be able to ensure that Coca-Cola remains the same taste, it needs to be precise, even to the smallest ppm, parts per million. It needs to be precise. And how do you achieve this? You achieve this through automation. And you have to do the design of all of this from the beginning. First, you have to concept the idea. The idea needs to come. For example, the way we are thinking about having an egusi processing or production company where you have to have egusi being cooked. Actually, we can design this and we have egusi. And on the assembly line, you have on the conveyor belt, you have egusi moving through sessions, timed and programmed. Okay, we can have this. But for us to have consistent taste of egusi, we have a lot of things we need to do. And that is process engineering. Now I'm going to break down the rules into different areas. Most times we always think that it has to do with design. This one is always what comes to our mind. Design and the simulation. This always comes to our mind that this is process engineering. But process engineering actually has to do with all of these things you see here. Usually, when companies advertise for roles, process engineer, they have an expectation for you to have idea of this, idea of this, idea of this, idea of this, which is entirely impossible for you to be an expert in all of this, except you've spent a considerable amount of years in the industry, probably 30 years before you can actually be this, right? And then they can now call you a senior process engineer. You spend a considerable amount, you've handled different projects, you've gone through different facilities, and you have the experience. Sometimes you might not entirely have all the experiences from all of this area. You might be lacking in one area, but you have experience in the other two or three or whatever. But you are able to pull teams together. You are able to pull other teams who are skilled in these areas, and then you have a process engineering team. Okay, now uh, now let me start with process design engineering, which is the one we usually do in the school, and also this one. These are the ones we usually do in the school. They are usually in the school curriculum. Okay, so process design engineering has to do with the design. Okay, I have to be conscious of time. We have 9:44. It has to do with the design of production systems. This is where you create the preliminary PFDs and P&IDs, and also the basic design specs. So your PFD, your process flow diagrams, and the piping and instrumentation diagram. This is the job of the design, and also the material and energy balances. This is the job of this guy. This is the job of this guy. This guy, this is his responsibility. Now, coming to the process operations engineer. This is where you have to apply operational skills in the industry. You have to have knowledge of the equipment and how the equipment work and uh, how the equipment. You have to anticipate failure of the equipment. and how to fix it, and also how to improve the operation of the equipment real time. For example, a refinery. Now, the people who operate a refinery, these are the operations engineers or operation technicians. I'm sure you see some of these roles most of the time. This is the easiest part you can join the industry here. As a fresh graduate, this is the easiest part you can join because most times there are graduate trainee roles in these areas where you can start up in the industry. Okay, now that apart, not to say that there are no entry level roles for this. There are also entry level roles for this, but usually companies do not want to spend time training employees in this area. They want people who are already experienced. Doesn't mean it doesn't exist for entry level roles. However, this is this is where people usually get into the industry. For example, you also have a foam industry, foam production industry. You have to mix some chemicals and do whatever. I don't know the process, but the guy who works in the foam industry, he is probably a process operation engineer in the foam industry. Now, most of us, we always look at oil and gas, oil and gas. There are different areas we can actually be as a process engineer, either process design, operations. We can be in the brewery industry, you can be in the pharmaceutical industry, you can be in oil and gas, you can be in even the paint industry. You have to design a process. There are skills you use for your separations. All of these are process engineering. So, although we usually target where the money is bigger, and sometimes we pay the price for it, for targeting where the money is bigger, and forget to spend time where we will learn a lot, right? So anyone who is in the industry already, the aim should be to find yourself gathering skills in all of these areas. Now, the process simulation engineer, this is where you have to do with your Aspen HYSYS, Aspen Plus, of which this is licensed. Anybody here has Aspen Plus or Aspen HYSYS in its computer? Probably you have a student version, your school already got the license for you, but most times you have to pay for the license, and it is expensive. It's not cheap. So, but the free version, which is DWSIM, I don't know if you've heard about it before. Have you heard about DWSIM before? If you've heard about DWSIM, can you just drop a reaction so that I can see how many people who already heard about DWSIM prior to the planning of um this meeting? If you've heard about DWSIM, anyone? Just drop a reaction. Okay, Caleb has heard about DWSIM. Okay, I think Shahima also Desmond. Okay, so I think some of us already heard about DWSIM. So it's an open source software. The team who built this software, they made it open source, so there's continuous development of this. And that reminds me also, even as a process engineer, whether you studied petroleum, you studied whichever chemical, you studied petrochemical, you can also go into coding. I didn't mention that, but that's a very special area. It has to do with consultancy. You can go into uh, okay, Marshall, not Caleb. Okay, sorry. So you can also go into coding, and the languages you need to learn are usually the Python. This is the most sought languages. At least here in Europe, where I'm based, I've seen process engineering roles that require coding experiences. Yeah. So for the guy who is in computer engineering, this could be a chance for you to gather skills in this area and also leverage on your coding skills that you already have. So for those who are already in the chemical process and petrochemical, you can also um, you can also acquire coding skills to add to the skills you already have because there are lots of companies who are coming up with softwares like this. For example, uh, Pro 2, which the parent company is here in the Czech Republic. They're currently developing and they are improving their software, which is a competitor with Aspen Plus. Okay, so we have process safety engineer, which some of us already are in this. area in either in IT or in industrial training. So process safety engineering has to do with safety and environmental compliance, and also the safety design systems ensures code compliance. They actually have to do the checks in your P&IDs, ensure that your plan has safety considerations. Okay, so all these are process engineering roles, which you have the opportunity to get yourself into. Now, also other engineering roles, we have process R&D engineer and process R&D engineer, which I'm currently, this is my current role at Energy Research Center in the Czech Republic. And my responsibility is to do market research, reviews, and technology screening and develop new processes. Currently, I'm working on membrane separation systems to separate hydrogen from natural gas. Now, this is different from the process you're already familiar with, where you have your distillation column and you have to boil off uh, the lighter components through the top of the column, and you require a lot of energy for this. So you pay the price of the duty for this. But for membrane separations, this is a cold process. You operate it at ambient temperature and you don't require excess heat. And it's just separation. You pass natural gas through a membrane and it separates natural hydrogen from other components like methane and CO and CO2. Then you take care of the remaining components and use hydrogen for your ammonia plant. It actually has a lot of use case. So now this is process R&D engineer. Usually in this area is usually from startups because the ideas are usually concepts and they could actually be actualized or not. They could fail or they could be patented and be used in industry. Now, these are areas you can go into. Now, also you have commissioning and startup engineer. Actually, this one, you should have experience as a process operation engineer before you can become commissioning and startup engineer, because for this, you have to do pre-startup review. You have to go through, you actually, after the construction of the plant, you have to go through some pre-startup review. You have checklists, you have to go through them, ensure that all equipments and valves are the right positions, and also, you do test run and fine tuning of the equipment before you start normal operations. So this is the commissioning and startup engineer. And this role is usually, you find this role mostly in plants that have been down for a long time and then they want to start up again, or you find them in plants that are newly built and they want to start up. So before startup, they need the commissioning and startup engineer. So, but you need this experience to be able to go to that. Okay. So also you have the process control and automation engineer. This is the area where most people haven't gone to. You mostly find people from electrical, electronics, and computer engineering here, and sometimes instrumentation in this area. They go into the PLC programming and also the build up of DCS systems. So because they have to take responsibility of integrating all the systems, that when you click open on your HMI, that the valve opens in the field and ensures that operations are stable and uninterrupted. Okay. They also have to take care of the alarm tagging and the automation logic and the rest of them. So actually, this role also will serve the process operations engineer, because the process operations engineer has to use the control room to perform his operations for real-time monitoring. Okay, and we have the process consultant. The process consultant, he recommends design. Usually, it's when a plant is already have been around for a considerable number of years, and then you have a consultant that will come to do review. For example, we have the Port Harcourt refinery that's not been functioning. You require a process consultant who will come and make recommendations for design changes. We call it management of change, to make technological upgrades in the plant and also train personnel to handle new equipment. For example, like I cited, the Port Harcourt refinery and also the Cardinal refinery that are not functioning, those equipment require upgrades. So this is the responsibility of this guy to do this. All right. Now these roles interlock. They are they have where they interact with each other, and this chart will give you an overview of it. Okay. So we actually have just 5 minutes left, and
Oh,
I think with this 5 minutes, it's not enough to finish what I have for you today. But let me quickly rush through this. So the process R&D engineer, if you look at this chart, you have a dot here. Excuse me. He is responsible for the concept and the feasibility. Usually the feasibility studies, for example, an idea that never existed, he comes up with it and okay, we can do this. So let's start it up. For example, all the process equipment you have in the industries came from this area. It was a concept initially. They thought about it, okay, let's come up with this. How do we put something in some container in a vessel and do some construction in it and is able to do some separation or do perform some operation for you and you have a different product at the other side. So yeah, that's this. And also the design engineer, they are also involved in the concept and feasibility because they have to design what the concept, they have to design it. And also you have the environmental sustainability engineer. I never mentioned this before. They have to do with the environmental rules and regulations. They have to ensure that whatever product or activities do not harm the environment, that life, aquatic life and terrestrial life remain intact. So all of these are considered during your process engineering life cycle, project life cycle. Then you also have the process consultant. He's usually there at the beginning because he's more of like a very experienced person. So he can make recommendations for changes in the beginning. Okay. All right. So also this role uh, is also overlaps with the process simulation engineer at the second stage, design and simulation, and also the process safety engineer, process automation. They all work together at this stage for the design and simulation. And also in the construction, process safety engineer has to be there for the construction. The automation also has to be there because you have to do your wiring and your terminations of the cables and the equipment as well, with the field equipment and the control equipment. And the commissioning and the startup engineer, of course, he has to be there for the commissioning of all this that has been done throughout all the stages. Okay. Then we have the operation and optimization. This is where you have the process safety engineer also, he has to be there. Then you have the automation, he has to be there in case of problems, maybe failure of equipment, the automation logic has problems. This guy has to be there to take responsibility. Then also, at this point, you don't need the commissioning engineer because the plant is already started up and running. So now this guy is the primary responsible is the primary custodian of the plant at this point because he has to operate the plant and ensure that the product quality remains standard. And of course, your environmental engineer has to be here also, which overlaps with the safety engineer. Okay. So, and the process optimization, because during the running of the plant, sometimes you have the process optimization engineer. He has to take, for example, a column is not separating properly. You're having bottom products at the overhead. You need the optimization engineer to run some simulations with your ISIS, and then he's gonna recommend new temperature to adjust or new pressure to adjust in your columns, and then the operation engineer has to effect that change. And of course, the management also has to be involved, and then also safety and the environmental engineer to ensure that life and property remain intact, and then operations continue. Okay. And also the process consultant, he can also be there because he can always be called in any point in time during the plant. He's always there at all times. So usually this big guy you will see probably some guy who's been there for 60 years in the industry or maybe some expert or whatever. And then also at this point, the commissioning and upgrade. Process consultant is also responsible for this. And as well, I didn't forget to mention the maintenance teams and the rest of them. They are also involved in this. But because we are focusing on process engineering, I didn't mention that. So I think this is where we have gotten to today. I think we will stop here because we only have 1 hour allocated for this. So do we have any questions so far?
Yeah.
Any questions so far? Yes, go ahead,
Okay.
Anthony.
Sorry.
Alright.
I am performance manager at Lecture Hub, so I know that 2 hours have been allocated for all the classes, except you want us to do just 1 hour.
Oh, two
We can do
hours.
2 hours,
Okay.
1 hour, 30 minutes, 2 hours.
Okay. All right. I didn't receive this update earlier. I'm just receiving this right now because I only budgeted 1 hour for this lesson, for this
That's
meeting. So
maybe subsequent classes we can do 1 hour, 30 minutes or 2 hours.
yeah, okay. Subsequent meetings we can go that far. All right. So thank you for informing me. Thank you for that information, though it came late. So I'm sorry we can only do 1 hour today because I have other activities I must attend to in preparation for tomorrow. So yes, Nidu, go ahead.
Alright. Okay.
Okay, I have a question.
Um.
Can these slides be shared to us? And also the record.
Okay, I think it's being recorded. So I don't know the plan for Demi
Yeah, let me
and
respond to
Anthony.
that.
Okay.
Yeah, for the recording will be given to the mentees at the end of the session, the end of the mentorship program. But you can go on YouTube to watch. We stream live, so you can go on YouTube to watch the videos again. But for the recordings, we really get that at the end of the training. Then for the slide, I think Engineer Kimakona will be the right position to answer that.
Alright. Alright. Thank you very much, Anthony. Thank you very much, Engineer Harlan, for this wonderful session. I think I've learned so well today. I've learned about process engineering, who a process engineer is, like different branches of process engineering, and I'm very sure every one of us have learned one thing or the other. So if you have a question, can you raise your hand, like the virtual hand, or you drop the question in the chat box? Let's do that within 2 minutes. So if you have a question, just raise your hand, just raise your virtual hand, or drop the question in the chat box.
Okay, I can see this
Right.
one. This one has his hand up.
All right,
This
this
one.
one, can you unmute your mic and speak?
Okay, sure. Thank you very much for this section. Please kindly confirm if you can hear me.
Yes, loud and clear.
Okay, sure. I have seen the different categories of process engineers in the industry. Yes, I've been following this process engineering for a while now, though I've not been practicing due to the fact that I've not had the opportunity. But so I want to ask for, let's say, the recent graduate who is looking forward to process engineering, how can such graduate be able to like focus in any of these categories? Like for me particularly, I am interested in the process safety engineer, process simulation engineer, and this process design engineer. So how can one? But the one the most important one to me is the process safety engineer. So how can one actually get to know and practice more of process safety engineering? Thank you very much.
Okay, thank you very much for your question. Okay, actually, the way to for you to get yourself involved is by getting a job. It's not easy. Yes, I know it's not easy to get a job in these areas because most times they require experience. But the easiest way is to go into a company as at the entry level. At the entry level. The reason is because most times the things you will learn will be on the job. Most things will be on the job. You could actually go on self-learning or self-training, and um, this self-training or self-learning will help you prepare for interviews. to help you defend yourself in interviews because you're not new to it. The terms are not new to you. You're able to articulate your ideas together and say something about it. You're able to think about you're able to explain what you know using real life situations because you've been studying. The truth is that for you to be a process engineer, you have to be studying. It's like studying medicine. Your role depends. Uh, your role can actually take people's life. Is that important? There's also an aspect that I didn't mention here, but because it's in the other slide, where you have the rules and regulations aspect, where you have the EPAs, environmental protection agencies, and all of those things. So uh yeah, you need to self-study and you need to do it aggressively. Like you need to really put yourself and soak yourself inside it. You need to be hungry for knowledge for you to be able to get into these roles because the competition is actually very tight. That the competition is very strong. So yeah, but there is hope. There is hope for everyone. There's actually hope for everyone because these opportunities they come up from time to time. But you need to prepare. Preparation is the key, and you need to apply. Apply for every role that you see. Every single role you see, apply. You might look at yourself, oh, these are the requirements in the CV and the job description. But then look at my CV. I'm still a fresh graduate. That is self-hating. You don't have to self-hate or doubt yourself. Arrange your CV from your educational experiences, from your project. There's always something you can pick up from there. And as God may have it, we have AI today. We have ChatGPT. You can just take your what you studied in your school and just put some of those experiences you studied and ask ChatGPT or any AI to, hey, how can I? You also put the job description. How can I, from my academic experiences, tailor my CV to this job? And then it will marry whatever you have studied in school. You can even list the courses you studied and then put the job description side by side, input it into the AI, and it will tell you, it will begin to write the things that you have actually done. And that way you can see, oh, okay, I've actually done something in this area. That means I'm useful here. So you tailor your CV, and for every job you apply, you have to prepare a CV for it. Don't just use a generic CV and apply for a role. You have to prepare for individual roles. And you have to be hungry for knowledge. That's the way. That's the way to get it. And also network. Network. Attend. You have SPE coming up. Attend. You have NAIS. Attend. You have NOG. If you have the money, attend. You know, attend, attend, attend. It costs some money, but if you are able to raise money, that's why you need to. While you are studying what you're studying, or you are doing what you're doing, you set aside money for training or set aside money for networking and attend these events. Sometimes it's just a recommendation. Hey, put your CV here and then you get in and that's it. You do your interview. They could be lenient to you because you're already a familiar face and then you get into the industry. So that's just the only way. Studying, applying, networking. That's it. And of course, the element of God. So yeah, that's it. I hope I answered your questions. Okay, I
All
have
right.
questions.
Let's now answer your question.
Yes, yes, you did. Thank you very much, sir.
All right. So thank you very much, Sir Engineer Allen, for that detailed explanation. So we have question here in the chat box, and I'll be reading it out for you, sir. So the question says, is data analytics, data science relevant to process simulation engineering? You mentioned that they write code with Python. So did you get that, sir?
Yes, I got the question. So, is data analysis, someone should please mute the mic.
Please,
There's
can
noise
you?
coming from somebody's background.
Yeah, I've muted them. Sorry for that. Sorry, the mic is muted, sir.
Okay. Oh, sorry about that. So you've not heard what I just said for like 2, 3 minutes. Okay.
Yes.
All right. So what I said is for process simulation, you need Python for writing codes for your simulation softwares. Your simulation softwares are like a spreadsheet. They're like Excel, but it's like a complex Excel such that for you to be able to do your calculations, you also do your pictorial view of what you want to compute. You have your input streams, your material streams, your energy streams. Usually, if you're doing your material and energy balance, you do it by hand or you do it with Excel. You do all of these things. You apply all the laws. Now, for your simulation, these laws have been encoded into the simulation software, right? They've been encoded into them. So there is an aspect of building these softwares which requires these languages. So if you're able to learn these languages and you put yourself in this direction, these are different directions you can put yourself. You can direct yourself. Like, okay, this is what I want to do. You can actually learn these languages in these directions, right? Specifically for these directions. Although you have wider applications because you can go into building apps for yourself and stuff, but also you can use it for simulation, for building your apps for process simulation. This is a very big project. You actually need a company to be on that to help you to achieve this. For data analytics and sciences, okay, yes, you need it to analyze your data, but most of the time the software does all your analysis for you. It does all the computation and does the analysis for you. So you could take the skill from your data, from your simulation as a data analytics skill or a data, should I say data science, because there's infusion of AI with this simulation these days is going beyond where we used to know it where it used to be. So yeah, that's where you can apply your coding skills in process simulation engineering. So
All right. Thank you very much, sir. Did that answer your question? Did Engineer Allen answer your question?
Yeah, yeah,
You asked.
yeah, very well.
All
Thank
right.
you.
Thank you. Thank you very
okay.
much. Do we have any other question? If you have a question, can you raise the virtual um and before we
Okay.
close the meeting for today?
Shahima,
All right. Please speak.
Yes, please. My question is about uh the the sectors of the petroleum industry. When you take the process engineer, it seems they limit it more to the downstream sector of petroleum. So I want to know about role of process engineering in the upstream and midstream sides too. Like, is it that much broad, or they have specific roles which are related to process engineering?
okay. All right. Thank you for your question, Shahima. All right. Process engineering, like I explained initially, is very broad. So for each industry, based on the need and requirement at different stages of the project. That's why you have this here. So in the upstream, you're basically going to, most times these areas are already, like, most of the concepts are already done. They've been done in the 80s. For example, your distillation column remains the same. The technology for uh, drilling remains the same as far back as the 90s or the 80s, right? They've not changed. So in these areas, concepts are everywhere. And in the textbooks, in fact, the textbooks you've read, you've used, they are basically the same, even up to date. The only difference is that, okay, they are being explained in a much simpler way. They were more abstract in the past, but now they are being explained in a more simpler way, right? Uh, so your question, how process engineering is being applied in the upstream, is being applied in the upstream. Yeah, it's applied in different ways. Uh, and this chart here will give you a guide of how you would apply it in the industry, because all of these areas you need it. You need them even in the upstream. It applies to upstream, downstream, even the midstream. It applies to all areas. You just have to figure out, okay, which area am I more aligned right now? Which area do I have more skills? And I can push myself towards this direction, upskill more, and prepare myself to get myself into the industry. Sometimes you might even be preparing yourself for one of these areas. Some of these areas you're not able to prepare yourself without getting a job. For example, this one is really difficult because you have to go from an operations engineer to a commissioning engineer, right? But you can also study. If you study and know how the equipments work, you can get yourself there. For example, can you mention one equipment you have in the upstream?
Okay, Derek.
Okay.
Okay, let me say Derek. Derek.
Yeah, a derrickman. Okay. This is one of the roles in the oil upstream industry. A derrickman is basically a technician. Am I right? Because uh, my experience has been in the midstream and downstream, this area. So, in as much as you are also looking for a way to break into the industry, I am also trying to break into the upstream, come from downstream to the midstream, and hopefully I'll get myself into the upstream. And then this, all of this will be demystified also for myself. So even for myself, I'm also studying and even preparing myself. So the thing is that whichever area you find yourself here, it applies to upstream, downstream, midstream. Uh, it applies to also manufacturing industries. It also applies to pharmaceutical industries and even areas you don't even expect. The only thing is that we always look at the oil and the upstream. This is where everyone's eye is, the bigger cake. Yeah, the bigger cake. This is where our eyes are on. But you don't have to like just have this tunnel vision that, oh, it must be upstream. You can prepare yourself. These skills, nobody will take them from you, take them away from you. You have these skills. And you see any of these areas you apply, you get yourself into the job. And from there, from entirely, you can move from one company to another. Okay? So yeah, that's basically it. So do not feel okay, these things they look like they are only applicable to the mainstreams. No, they're applicable to all areas because you're basically gonna have your concept, design, construction, operations. But most times in the upstream you find yourself at the operation and optimization. Yeah, well optimization and stuff, then operations of the well and all these things. This is where you mostly find, except for newly constructed wells, you have construction and commissioning, which all of this are also applied. You have all of this also applied, as well as the petroleum engineer and the geologist and the rest of them. But here we are only focusing on process engineering. But these roles they interlap, they overlap with each other. So yeah, did I answer your question?
Yes, please. Thank you very much for clarifying this for me. Thank
You're
you.
welcome. You're welcome. I think we can take only one more question and we'll call it a day because only anticipated only 1 hour for this. And I'm already receiving
All right.
calls.
All right. Thank you. Thank you very much, Engineer Allen. So do we have any other question? Just one last question. Or she just if you have a question, can you signify your virtual and
Give me a moment.
I guess
I
there
will
are
take.
no
I
all
can
right.
see Jones Ulu. Just give me a minute.
Okay. That's it,
Sorry.
John. Just once it comes back, can you just unmute your mic and speak when it comes back?
Okay.
Okay. Yeah. Go ahead, Jones.
Okay, sir. Mine is not a question. Rather, it's a contribution. Please, sir, I want to say something on what Anthony Esse said about the time issue. So I want to beg, with due respect, sir, can we do it this way? I'm not trying to impose it on you. I'm just trying to beg you. Can we do it this way? Since Anthony said it's 2 hours per section, can we do a class of 1 hour 30 minutes? Then the 30 minutes should be question, because I've learned a lot from the question people ask. Thank you so much, sir.
Okay, I think I get you. It's a good suggestion. So we'll see. We'll see about that. I think Dami and Anthony, they are going to take responsibility of that. They've informed me now, so I'll just prepare for the next one. And probably 1 hour 30 minutes. I've already done 1 hour 20 minutes, which I didn't budget for. So so I think next lesson we can go 1 hour 30 minutes. Yeah. So, so yeah, thank you though. Thank you.
Okay,
Thank you.
All
so
right.
just before you go, I would like us to put on our video and then let's take
Okay.
a photograph, please, everyone. Dami, Jones, Enoch, Desmond, Blessing, Chinedu, who else? Caleb, Moses. Okay, so I'm taking the screenshot now. Can't see Blessing yet. Can't see Caleb.
Smile, guys, smile. Only Dami is smiling.
Okay, so I'm taking the next one. Blessing and Masha. Can't see you. Okay, thank you guys. That'll be all for the photograph.
All right.
Okay.
Thank
Over
you
to you,
very much,
moderator.
Anthony. Who is reading Ant? Do you want to say something?
No, I said it already now.
Okay.
All right. Thank you very much. Can we all give our mentor a virtual upload? Can we all appreciate our mentor in the chat box? If you really learned today, can you just drop something in the chat box? I want to see the excitement. I want to see the excitement. If you've learned something today, I'm not seeing anything in the chat box. All right. I can see one. I'm still expecting more. We are 13 on the call. Let me just see without mine is as mentor. We are 12 on the call. We really okay. Thank you very much. Thank you. Let's keep it coming. Despite his busy schedule, he still joined us today. Thank you very much, Engineer Allen. We don't want to waste much of your time. Personally, as I said earlier, I've learned so well. So I will encourage every one of us prior to the next session, prior to the next class, let's learn more about all these things. Let's learn about process engineering, where process engineer is, the different aspect of process engineering, so that we'll come back fresh next class. So thank you very much. I'll update us on when our next class will be. Let's stay tuned. Let's stay active on our WhatsApp group and our Google Classroom. Thank you very much, Engineer Allen. Thank you once again, and do have a wonderful night's rest.
Thank you very much.
So thank
Thank
you,
you very
everyone.
much, everyone, for having me. And have a wonderful night rest. And see you next time. Bye.
Thank you so much, sir. Bye.
Good night, sir.
Good night.
Good night, everyone.
Good night, all.
Good night, Desmond. Good night.
Wait, Anthony, is it? I did your DM.
Thank you very much, Anthony. Thank you.